In this concept, we're going to talk about prime and composite numbers. So a prime number is a whole number that has exactly two different factors, one and itself, okay? One and itself. Some examples of prime numbers include the number 2. And 2 is actually a special case of the prime numbers in that it is the only even prime number, okay? 2 is the only even prime number, which means that all the other prime numbers are odd, okay? So all the other prime numbers aside from 2 have to be odd, okay? So 2 is the only even prime number. And again, it is a prime number because the factors of 2 are 1 and 2 itself, because 2 goes into 1, giving 2, and then 2 divides by 2, giving 1. There are no other factors for 2 beyond 1 and 2, so it is considered a prime number. Another example of prime numbers is the number 3. So again, 3 has only two factors, 1 and 3 itself. So 3 divides by 1 to give 3, and then 3 divides by 3 to give 1. And that's why 3 is considered a prime number. Another example, 23. So 23, again, has no other factors beyond 1 and itself. So 23 divided by 1 gives 23, and then 23 divided by 23 gives 1. So then here, this is an important note to keep in mind. The number 1 is not considered a prime number because it has 1 and itself, which is 1, as factors. But these are not different factors. They are really the same thing. So technically speaking, 1 is not considered a prime number because it only has one factor, which is itself, 1. Okay? A composite number is a whole number that has more than two factors, okay? More than two factors. So some examples of composite numbers are, so the number 8, for example, right? So the number 8 has, well, all composite numbers have as factors 1 and themselves, okay? So 8 has as factors 1 and 8, but then it also has additional factors beyond 1 and 8, okay? So 8 divides by 1 to give 8, and 8 divides by 8 to give 1, but it also divides by 2 to give 4, or divides by 4 to give 2. So 8 is a composite number, not a prime number. Another example is 4. So again, 4 divides by 1 to give 4, and it divides by itself to give 1, but it also has 2 as a factor. So 4 goes into 2 and gives 2. Okay, another example is 25. So 25 divides by 1, again to give 25, and it divides by itself to give 1, but it also divides by 5 to give 5. The goal is so the point of composite numbers is where you have these factors that go into the number without giving a remainder. Okay, so you carry out this division and then you don't get a remainder in the end. That's how it's considered a composite number. Another important technique to keep in mind here is prime factorization, which is expressing a composite number as a product of prime factors using something called a factor tree, which is what we see here in this example. So essentially what we do is we start with a composite number such as 16, and we keep breaking down the factors until we get to the set of prime numbers, the set of prime factors that make up that composite number, where you can't divide these prime factors any further. So as an example, 16 has as factors 4 and 4. So 4 times 4 gives you 16. And then each of these 4s breaks down further to 2 times 2. right? So 4 breaks into 2 and 2, and then this 4 breaks into 2 and 2. So we say that the prime factors of 16 are 2, 2, 2, and 2. It was chosen here to break 16 down into 4 by 4, but we could have as well broken it down to, 8 and 2, for example, right? So 2 is a prime factor, so that can't break down any further, or can't factor down any further, but 8 can be factored further, right? So 8 can factor to 4 and 2, right? This 2 is a prime factor again, but the 4 can break down further into 2 and 2. So again, we have 2, 2, 2, and 2, which is the same as what we had here. Okay? Now it's your turn. With the examples that we have, please pause the video, work on these, and come back for the solution. Okay, so the goal is to identify the following numbers as either prime or composite, and then to factor into primes if possible. We start with the number 25. Again, we did this earlier in the example. So 25 breaks to 5 and 5, right? 5 and 5 are prime numbers. So the prime factors of 25 are 5 times 5. So this is a composite number. 25 is a composite number because it breaks down further. It has more factors than 1 and itself, right? So 25 has the factors 1, 25, and then 5 also, right? So these are the factors for 25. That's why it is a composite number. The number 13. The number 13 has as factors 1 and 13. It is not divisible by anything else without a remainder. So 13 is a prime number per the definition we talked about earlier. Okay, 72. Now, 72 is clearly divisible by 2, right? Because this digit is even. So 72 breaks down to 2 and 36. 36 breaks down further to, for example, 6 and 6, right? Each of these 6's breaks down to 2 and 3, and then 2 and then 3 and 2. So the factors, the prime factors of 72 are 2, right? 2, another 2, 3, 3, and 2. So 2 times 2 times 2 times 3 times 3. And 72 is considered a composite number. $28. So 28 breaks to 7 and 4. 7 is considered a prime factor. Cannot be, is only, 7 is only divisible by 1 and itself, 7. So 7 is prime. 4 can be broken down to 2 and 2. Each of these is prime. So the prime factors for 7 are 2 times 2 times 7, right? And 28 is composite. 51. Now that looks like an interesting number. If you try out to divide it, if you try some factors for it, obviously you'll have 1 and then you'll have 51. But guess what? It is also divisible by 3. So what do you get when you divide 51 by 3? Well, you get 17. Okay, so these are the factors for 51. So and 51 is considered a composite number. This is it for this video. See you in the next video.